inequalities. We need a spelling on that? Oh. It looks a little like this. Inequalities. And for those of you that are observant, you will notice that there's something strange about this. Lauren, what is it? Yes, we're not looking for things that are equal. Something's telling you things that are not equal. They're not equals. And we have inequality signs, don't we, Zach Roth? What are inequality signs? Do you know? Things that tell you things that are not equal to. Yes, look at Zach. See, there's a reason why he was bent ill for the last couple of days. This is the greater than sign. And I know some of you still struggle with which one the alligator eats, but I can't change that. It's about time you kind of figured that. This is the less than. I don't know if they give you, do they give you the other ones? Yeah, I suppose we do. We have, yeah. Then you've got, if you put an equal sign underneath of it, it is greater than or equal to. And there's the less than or equal to. And then there's some lesser known ones that I don't even know if the book asked you, but because you guys are probably the smartest 7th grade class I've had in some time. We have this little thing. Guess what that's called? Fisher, I heard it. What'd you say?
Not equal to.
Not equal to. There's got to be more. Is there some? Well, and then, I don't think they give you these. You're not quite that smart, so I won't go any farther than that. Now, please understand this. We've done this before. Well, let's just do a couple. If you're given this, x is greater than 5. Okay, you must understand that really you cannot tell me an exact answer for that, right? Cassie, x is greater than 5. What is x? Well, yeah, what is it? Give me. Soph says 6, and I'll say, yeah, that's right, but you're going to tell me any number higher than 5. 8, yes, you're correct. Joseph? 10, all those numbers are true. So really the only way you can kind of show your answer for this, I'm not kidding about you two, by the way. The only way you can show your answer to this is graph it on a number line. Graph on number line, which means this. Watch how very simple this is. And by the way, this is the bare minimum I need. If you were an extra overachiever, if you were a Clausing per se, you know, you could sit down and do this. 2, 3, 4, 5, 6, 7, 8. And if you were showing me this as an answer, here at 5 you would put an open circle and you would color in the side of the line where all the answers that are bigger than 5 are, which means you would do this. And then you put an arrow this way. Why would you put an arrow there? Because it goes on forever. Okay? This is an open circle because 5 is not an answer to this. Is 5 bigger than 5? No, it is not. It's the same as 5. But is 5.1 an answer? Yes. So the way you show that it starts at 5, but it doesn't include 5, is you put an open circle. If my inequality looked like this, it's going to be the same exact graph, except instead of an open circle, because it does equal 5, you will color the whole solid dot in. And it goes this way. This, by the way, is the bare minimum that I need to see. You don't have to jot down all those numbers, but you do need to put the number that's there. You do need to put the circle colored in or outlined, and you do need to have a solid line colored one way, going the other way. And I really would like you to have some thin line going this way just to show that it is that thing, but I need to have just that. Now, some helpful hints to you, Joseph. Helpful hints to you are this. Look at this. You see this? Notice how this and the arrow that you color in are very similar and the same. And it will happen that way with everything that you do. Whatever that sign is really the sign. Example, if you get x is less than 3, here at 3, open circle or closed, somebody, open, goes this way, it's the numbers less than 3, so this, look at same sign thing, are the numbers that are less than 3. Who feels like they're going to struggle with that? Well, the brutal honesty is good. Now, here's where you will struggle, children. Listen very carefully. Because this really is, did we do this before? That would require a response from somebody. No. We've never graphed inequalities before?
No.
Aaron, yes or no? No. Well, unfortunately, this is not as easy as it gets because the book will give you something that looks like this. 3x plus 1 is less than or equal to 9. No, 8. No, let's go 10. Okay. This is an inequality because it tells you that they're not equal. Actually, it has an equal sign too because there's a person equal there. But when you see this, ladies and gentlemen, you have to solve it like it's an equation. You need to find out what x is less than or equal to. You need to come down and get x is less than or equal to some number here so that you can graph it. And it is done the exact same as any complex equation would be. What would be the first thing I would have to do here? I need to get rid of the 1, and I do that by, Andrew, subtracting 1. I subtract 1 and I get 9 is less than or equal to 3x. If this was an equation, then I would do what, Chase? Get x by itself, I now divide by 3. Now x is by itself. And then x is less than or equal to 9 divided by 3 is 3. Are you with me on that? So that's what my thing is. If it asks me to graph it, then here at 3, is it an open circle or a closed circle? Chime in there anytime you feel like it, 7th graders. It's an open circle. No, it is not an open circle. If it can be equal to, it's closed. What side do we draw the little arrow on? Since it's this side here, it's going to be right here. And you go here. Now, lest you think it's all that simple, here is what you must look out for. When you deal with inequalities, okay, if you see this, 5 is less than or equal to x, this will make you sad. Anybody know why? Madison, take a shot at why this makes you sad.
Because it's the opposite way around.
Yeah, we don't do inequalities like that. Inequalities must have the variable on the left side. Must have letter on the left. Or the left. Okay. In normal equations, that's not such a big deal, right? Because if 5 would equal x, I can just flip those around and x equals 5, yes?
Yes.
But that's not the case with inequalities. You're not allowed just to start moving things because these things tell you things that are not equal. Okay, you can flip-flop these things. It is possible to do, but if you do it, the sign has to flip-flop too. A good way to think about this, Joseph, is you remember back in 1st, 2nd, and 3rd grade when this little guy was the alligator and he always ate the bigger number? Okay, the alligator is eating the bigger number, whether the bigger number is on the left side or the right side. So if you move the bigger thing to this side, the alligator understands that and realizes that the x is still bigger, so he turns and goes the other way too because it's still bigger. Okay, so if you find the variable on the wrong side, you can flip it around, but you have to flip around the inequality sign too. Okay, and when you graph it, obviously at 5, it's an open or closed circle. Thank you for the one person who cared. And then it goes this way. Who was that said that? Emmy, take 3 problems off your assignment tomorrow just because you are participating. Just because. I like a response once in a while. Now, what else do we have to look out for? What else do we have to look out for? One thing we look out for is the letter on the wrong side. The second thing is the letter must be positive. Somebody say, are you sure?
Are you sure?
I am positive. So if, when you get to the end of your equation, it looks like this, negative x is greater than 7. Let's look at, in a normal equation, what would happen? If you had negative x equal to 7, how would I fix that? Because it's true also in equations you can't have negative letters. What would you do there? Madison?
You would put it on the bottom of the fraction.
No, that's negative exponents. There's no negative exponents. In normal equations, you can just make this positive as long as you make that negative. If negative x equals 7, x equals negative 7, that's fine and dandy. With inequalities, ladies and gentlemen, you can still do that. Except, here's the deal. If you change this to its opposite, and this to its opposite, you have to change this to its opposite, which means it's going to flip around and go like that. Opposite, opposite, opposite. So when you graph it, it becomes negative 7, open or closed.
Open.
You would think after that last thing, and me giving Anderson problems off, somebody would have jumped on that bandwagon. It's like this. So do you see the 2 things to watch out for? Watch out when the x is on the wrong side. Watch out when it's negative or positive. Let's look at some hard problems, shall we?
We shall.
Overcome.
We shall overcome.
Right out of the book, let's look at the absolute hardest problem you could possibly ever conceive of. Oh yeah, here we go. Well, no, let's do an easy one first. 6x plus 1 is greater than negative 5. 6x plus 1 is greater than negative 5. Should I have you see how many of you can do this and actually get the right answer or not?
Yes. Yeah.
All right, you give it a shot. You should be just about done. It doesn't take long. Remember the lookout rules that I gave you not very long ago. See if any of those apply. They maybe don't apply to this one. I don't know. But they will eventually apply. Are we done? Solve just like an equation. Done? Close? And as I look at this right off the bat, ladies and gentlemen, I'm going to tell you I don't have to change the sign because I'm not going to get a negative x, and I don't have my x on the wrong side. So whatever sign it is, it's going to stay that sign. It's going to end up being greater than in the end of this thing. Your number can be negative, x can't be negative. So you should have, did we? Joseph says, the first thing I have to do to solve this, Joseph, is
Get x by itself.
Yep, which means the first thing I have to do is, Joseph?
Subtract 1.
Oh, good. This would be the first place where numerous people would go wrong. What is a negative 5 minus 1?
Negative 6.
Thank you very much. Anybody not get negative 6? Why not? 5 negative signs and another negative sign is a total of 6 negative signs. You're not multiplying there, children. It's not a negative times a negative. It's 5 negatives and another negative is 6 negative. Now what do I have to do? Simply to get x by itself, divide by 6. Divide by 6. What is, now I'm multiplying and dividing, by the way. What is negative 6 divided by 6? Negative 1. I don't have to change the sign. It's fine if that number is negative 1. Graphing that simply is at negative 1, open or closed?
Open.
So there's all over that there. And you end up with that. How many people actually got pretty much to that point? We're in our national average there. This would be the point where you'd say, I don't know why we did do this, so.
I don't usually have my it's open.
If there is this, if there's a little equal sign, it's closed. No equal sign, open. Only thing, see, no equal sign, open. Equal sign, closed. That's a good question. Always want to check that. Now, let's go for the juggler. Ready?
Yeah.
Well, no, yeah, no.
Yes.
Sure, why not? 7 is less than or equal to x minus 8. Solve and graph. Go. No, we're not. We will not accept that book. We will not accept that. Why would they do that? There are times when I don't understand. Done. Oh, I see. All right. Let's see what we came up with here. First thing you did, John, is and there are a couple different things you could do first, but I would probably do what first, John? John, work with me here. Help me out. Take a shot at it. I'm not going to yell. I've rarely yelled at anybody. Sometimes I do. Yell at my dog. She's hard to hear. Very hard. John, what would you think? Whatever you're going to say probably is right, because I think we could do it any way you said. You mean nothing, John? All right, Leighton, see what you say.
X is greater or equal to negative 15.
Wait, I don't want the answer. I want the first thing I do.
You get rid of those.
All righty, well, let's do what Leighton said. In order to get rid of 7, I have to subtract 7, correct? This would not be the way I do it, but you can do it this way. I get rid of 7. By the way, I'm left with 0 now over here. What is negative 8 minus 7?
1.
It is not.
Once
again,
15.
8 negatives and 7 more negatives is negative 15. All right. I wouldn't have done it that way, but it can be done that way. Now the next thing I would do, Leighton, is
Remove the greater or equal.
why would I change the greater equivalent sign?
Remove
Sure, let's move the x. How do I get the x over there? I have to subtract it over. So I subtract x, So now look, I've got negative x less than or equal to negative 15. Now we're getting close. Now what? It's not right yet because I can't have a negative x. What's my fix? Opposite, opposite, opposite. X, opposite, opposite. This technically is the answer. And graphing it would be closed circle. And it goes, look at that little arrow, anything greater than 15. Everybody get that? Oh good, 3. Now again, I wouldn't have done it that way. Aaron, did you do it that way? Let's, you can do it that way. I don't, it's not that big of a deal. Let's look. Aaron, what did you do first? Say what? Yeah, Aaron says, well, hey, it's always nice to have the x on the right side. So if you take, did you take this whole thing and this whole thing and flip-flop them around? You can do that, x minus 8 and 7. The thing is, when you flip it around, remember, alligator always eats the bigger thing. It's still the bigger thing, so you'd end up like that. And then, Aaron, you did? Add 8, because it's add the opposite. Add 8, you get x is greater than or equal to 15. Everybody do something different? Connor?
I didn't get it right, so I just said that. You can switch 7 and x.
You can't just pull one thing apart. No, you have to switch the whole thing to the whole thing. Another way, this is actually, I probably wouldn't have done it Aaron's way either. I mean, it's fine. I probably would have done this. Well, I want x by itself, so I add 8, and I add 8. So now I get 15 is less than or equal to x. And at this point, I might have flipped it over here, put the x over there and the 15 over there, and switch the sign. But either way, you're going to get x is greater than or equal to 15. And graphing it would be, 15, open or close circle?
Close.
Let's close it, going this way. Alright, let me give you one more. Oh wait, no. No. 426, open your book, please. Open thy books to page 426. Everybody there? Look at example F because you have to be able to kind of pick this apart, dear 7th graders. Number 1, look at letter F. You with me on letter F? Is anybody in here's name Jan? Anybody have a middle name of Jan? Anybody have a mother named Jan? Anybody with a mother with a middle name named Jan? Anybody with it? Do you? All right, you get to read that problem for me.
Jan is participating in the 6-mile run walk for a charity. She completes the course and runs at least half the distance. Then the inequality shows how far she might walk. Learn the inequality.
What inequality shows how far she might walk? The key words there are this, children, and here's your job. If you hear the words at least, what inequality would be at least? Now, what you have to do is think of some, for examples in your head. Let's say 7. What numbers are at least 7? And then you would say, well, if I said to give me a number that's at least 7, first of all, is 7 a choice? Is 7? What in the world? Is 7 at least 7? Yes or no? So you know it can have the equal sign. And then what? I shouldn't answer that just because it's a telemarketer. So here, let me write that down. If x is at least 7, what inequality would be the same as at least? We just said it could be equal to, so you know it's going to have that thing there. Joseph?
Greater than or less than?
No, it's not greater than or less than, because less than would not work. It's
Greater
just simply
than.
greater than or equal to. Why? Because 7 is an answer, 8, 9, 10, any number 7 or bigger is that. What if the inequality, what if the thing said is at the most? What inequality is at the most? And again, just think in your head, if I said what is, if x could be at the most 3, what numbers are at the most 3, what inequality would you write there? Chase?
Less than or equal to.
Yeah, less than or equal to. What if I said no more than 5? What is no more than?
It's not equal to.
Is 5 no more than 5? Right, 5 is no more than 5, isn't it? So again, no more than would be the same as at least, isn't it? No more than or at the most. Or any other words we could use to compare? Let's see, what does it say here? Well, maybe not. In addition to, no. All right, we're gonna try a little math today. I probably will give you your test back maybe in a moment.